we do in this section and the next sections, I think smooths out for students a little bit. I think we kind of, once you get past proving identities and trig equations, in my opinion, the class gets easier. Okay, that's what I usually find. So what I'm going to do with this is, you can start this by just converting this to degrees if you want to, or you can look at a combination in radians if you want to. I always just look at this as degrees. So I'm just going to do this on the calculator. It's going to be something that's a special angle that we can get a combination out of. So if I do this, that will give me 165 degrees, okay? So that's all I need to know. All right, so here's what we're going to do. We're going to look at this as the sine of 165 degrees. So all you really got to do is look on the unit circle, try to find two angles that either add up to 165 or subtract to 165. Here's what I see. And keep it as simple as possible. I see 120 and 45. Those add up to 165, right? So find a combination that works. Okay, so let's go ahead and write down that we're going to do sine of 120 degrees plus 45 degrees. The rest of this is knowledge of the identity and the unit circle, which hopefully you got down by now. Okay, so that's going to be, the identity goes sine of 120, cosine of 45, so it's sine cosine. Then you do it backwards, cosine sine, okay, like that. And then you do the same sign. So this identity we said has same sign. Okay, so that's an identity hopefully you got right on your quiz. Okay, then what we need to do is just figure this stuff out. So let's do the, I did something wrong. What did I did that last one should be sine. So it goes sine, cosine, cosine, sine. My apologies. Okay, so let's see. The sine of 120. Look at 120. The y value is the sine. So that's going to be square root of 3 over 2. Cosine of 45. The x value is the cosine. And if you don't have that memorized by now, you need to get cosine and sine of 45 down, because it's just, that's the easiest one to remember. Shows up a lot. Cosine of 120 is going to be the x value, so that's negative 1/2. Okay, then the sine of 45 is the y value, so that's root 2 over 2 like that. Okay, everybody with me on that, okay? Okay, sine is y, cosine's x. Multiply it out, let's see what we get. So this is going to be square root of 6 over 4. You can go ahead and do the final answer if you want to, and that's going to be plus a negative root 2 over 4. And generally, you're always going to put this in a common denominator. It's already got a common denominator of 4, so we'll say square root of 6 minus square root of 2 over 4, that's it. Okay? And that could be checked on a calculator. You could actually do the sine of 11 pi over 12 in radian mode, get a decimal, and then you could type in your answer and it'll give you the same decimal, so it's verifiable. Okay, like that. Okay, I'm going to have you guys do one of these, and let's just kind of be consistent on this one next. So how do you want me to put together negative 15? What angles do you want me to use? Your call. What do you see? What would subtract to make negative 15 out of all those angles on the unit circle? And keep it as simple as possible.
0 minus 15.
Okay, 30, you could do 30 minus 45. You could also do 45 minus 60. And you could do it other ways as well. Let's just all do this the same way. Do 30 minus 45. Now you guys go ahead and take it from there, and then I'll leave my unit circle up there. If you can see that okay. Can everybody see that okay? Yeah, so just see if you can get that put together. I got the identity up here, and then just put it together. And one thing will happen on these problems, you'll always have a 4, a square root of 6, and a square root of 2. So if you're not getting those three numbers in some way, then something's going wrong, because it always works out that way, unless you're using like 90, 180, 270 and stuff like that. You'll always have root 6, root 2, and 4 in there. So that's how it works out. Okay? So it should be pretty straightforward. Students usually do very good on these problems if they know their unit circle and they know their identity. Okay? And this one, the other thing I want to mention on this is negative 15 is a quadrant 4 answer. It's a quadrant 4 angle. So you should get a negative answer because the sign of a quadrant 4 angle is negative. So when you get an answer, you should be able to see that, yeah, that answer is negative. Does that make sense? Okay. All right, I'm going to go ahead and write this out then. So you should have sine 30, cosine 45, and then same sign, so that's minus. Then do it backwards, do cosine of 30 times sine of 45 like that, okay? Go to your unit circle. Sine of 30 is 1/2. Okay, cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Okay, sine of 45 is the y value, so that's root 2 over 2 like that. So that's what you should get. And then when you put this together, you can write the whole answer in your head if you want to. That's root 2 over 4 minus root 6 over 4. So you would get the final answer, square root of 2 minus square root of 6 all over 4. Okay, that's pretty simple, isn't it? Okay, and that's a negative answer because the square root of 6 is bigger than the square root of 2. That's what I'd expect because negative 15 is quadrant 4. Okay, does that make sense? Yes?
If 2 minus 30 to 45, wouldn't that be a plus?
No, on the identity you use the same sign. See, we're using the sign difference identity. And on this identity, the sign's the same. So you'd have minus there. Okay? Remember, if you do the cosine identity, that's when the sign was backwards. But on this one, it's the same. Okay? Got that? Okay? All right, very good. Any other questions about that? Okay. Now, what we're going to do with this is kind of a typical thing we do is if you're going to work out this problem, a lot of times I put this same problem on a test and students like panic because they can't use their calculator. Now the sine of 20, you can't do the sine of 20 unless you have a calculator. But what this is this is the right side of the identity. So what you're going to do is you're going to put it together into the left side of the identity, okay? Because it has the structure. It's sine, cosine, cosine, sine, same sign. Okay, so you're doing the sine of 20 degrees plus 100 degrees, okay? I see that from students all the time. That's a good way to check if students really understand how the identity works. So now what that's going to give is the sine of 120 degrees, and then the sine of 120 degrees, just look up on the unit circle, that is, there's 120, so that's square root of 3 over 2. That's how you do it, okay? Because you can't do the sine of 20 and the sine of 100 without a calculator. Okay, does that make sense? So that's just looking at me given the right side of the identity and then working with it backwards. Okay, everybody got that okay? Okay, all right. Now, the next thing I want to do is on your handout on Canvas, there was 2 parts. So there was a second part. And this one, what we're going to look at now is the tangent identity. So the tangent identity is another one that I expect you to know. There's going to be some other identities I teach today that I will give you. I'll tell you what I do on this. And the tangent sum difference identities are a little more complicated algebraically. So you might run into some algebraic issues on this. So this goes like this. If you have the tangent of alpha plus beta, you have the same sign there. So you say tangent alpha plus tangent beta, and then you have the opposite sign there. That's the structure. So the numerator is just tan alpha plus tan beta. The denominator is 1 minus, and then the product of those two like that. Okay, same thing works here. See if it's the minus, see how you have a minus there, and you have the opposite there. Okay? Now, I'm not going to do a derivation of this, but I am going to explain where this comes from. So if you're like real bored during spring break and you want something fun to do, you could do this, and you would be able to do this very easily. The tangent is the sine over the cosine. So basically, we already know those two identities. We know the sine of alpha plus beta and the cosine of alpha plus beta. If you wrote it out and worked a little bit with that identity, that's what would pop out. Okay, it might take several steps to get there, but that's where that derivation comes from. So try it if you're interested. Okay, it's not that bad. Okay, so we're going to mainly start these problems off mainly the same way. So to start with on 75, how do you want me to put together 75? What's the simplest thing? 45 and 30, right? Okay, keep it real simple too. Use small numbers. So 45 degrees and 30 degrees add up to 75. Okay, I'm always giving you angles that you can combine, otherwise you couldn't do the problem. Okay, so when we do the identity on this now, it goes like this, and this algebra gets more complicated, so pay attention, and you might have some background issues with your algebra. So with the identity, you do the tangent of 45 degrees plus the tangent of 30 degrees. That's the numerator from that formula. And then the denominator, you go like this. You go 1 minus, and then you do the product of the tangent of 45 and the tangent of 30 like that. Okay? And since it's a fraction, you will get into fraction issues in this problem. So sometimes students don't do well with these problems because of the background issues in algebra. Okay, so what I'm going to do basically is these two things. I'm going to go ahead and we're going to look at the unit circle and we're going to figure out what the tangent of 45 is. And then we want to figure out what the tangent of 30 is. So how do you find a tangent on a unit circle? What do you look for? Y over x, right? Okay, so let's look at y over x. And whatever we can do in your head, let's do in our head. Okay, if you go to 45 degrees, what do you have? You just have root 2 over 2 divided by root 2 over 2, so that's 1, right? So the tangent of 45 is 1. Okay, that's nice and simple. Okay, that's how you do that. Now, if you do the tangent of 30, you're looking at this point, so you're doing y, which is a half, and you're dividing that by root 3 over 2, like that. The 2's really cancel out. You can do this in your head. But what I'm doing is multiplying by the reciprocal, so I get 1 over root 3. Okay, now I would go ahead and rationalize that before I plug into my tangent formula because it'll make it a little easier. You'll have to do it sometime anyway. So let's rationalize that. And again, you can do that in your head if you're confident in that. So you get root 3 over 3. So what we have is the tangent of 45 is 1, and then the tangent of 30 is square root of 3 over 3. Okay, that's stuff we've already learned how to do. Okay, everybody with me on that? Okay, now let's plug everything in and see what we have. So the tangent of 45 is 1. The tangent of 30 is square root of 3 over 3. And then the bottom we have 1 minus the tangent of 45, which is 1. And then the tangent of 30 is square root of 3 over 3. So that's the algebra problem that you got to work with. So we got to simplify two things. Okay, first of all, this is a complex fraction, which we've seen before. How do you make that 3 go away? You multiply by 3, right? If you multiply the top by 3, that thing's going to cancel out. And if you multiply the bottom, if you multiply the top by 3, you have to do the same thing at the bottom. So what we're going to do is it takes two main steps to get this simplified. I usually just teach it this way. So let's go ahead and multiply the top by 3, and let's multiply the bottom by 3. Okay, all I'm doing is a distributive property, and you want to do this in your head. You want to understand how this works in your head. So what I'm doing is distributing. So 3 times 1 is 3. Then when I do the next term, the 3's cross out, so you're left with square root of 3. Do that in your head. Just multiply it out, distribute it. When you do the denominator, it works exactly the same way. 3 times 1 is 3. You still got the minus, and then when you multiply this out, the 3's cancel out, so you're left with root 3 like that. Everybody follow that okay? Okay, that's a complex fraction. Now you got to dig into your background a little bit. We've talked about conjugates, right? I know that's showed up. So what you do now is you have to rationalize the denominator, but instead of just multiplying by root 3 over 3, you have to multiply the denominator by its conjugate. And the conjugate is just the same thing, but change the sign. So then the next stage you got to get to is you just got to know how to FOIL when you got radicals involved. Okay? Well, let's go ahead and do that. And let me know if you don't follow something on this, because this is an algebra background issue that you want to make sure that you're fairly solid with. So let me move that unit circle out of the way. Okay, so let's carefully go through and multiply this out then. Okay, so if I do this, the first term, I'm going to do 3 times 3, so that's going to be 9. I'm going to do the outside term, so that is 3 root 3. You can't put those together because one's in a radical, one's out of a radical, so it's just 3 radical 3. Sometimes students haven't done that in a long time, so they forget that. The inside term is the same thing. It's a positive times a positive, so it's positive 3 root 3 like that. Okay? Then when you go to the last term, If you're doing a square root of 3 times the square root of 3, that is a square root of 9, because you can put them together. Okay, tell me if you follow that. Okay, because that's real important that you do that correctly. Okay, now let's go ahead and do the denominator. You can do a shortcut. I'm going to go ahead and FOIL the bottom out. If I do that, the first term is 9. Okay, the outside term is plus 3 times the square root of 3. Notice the inside term is negative 3 root 3, so that's going to cancel. That's the reason why we use the conjugate, because we want that to cancel. Okay, then the last thing we do is negative times positive is negative, so we have square root of 9. So let me pause there for a second and see if there's anything that you don't understand about what I just did, because that's the algebra background issue that you must make sure you have down. Okay? All right. Now let's look at what we have in the numerator. These are like terms. Okay, so 3 and 3 is 6, so that's going to be 6 times the square root of 3. Okay, we know the square root of 9 is 3, so if I put these two things together, 9 plus 3 is going to be 12. So what I'm doing there is I'm just collecting like terms. I got 6 radical 3, and 9 plus 3 is 12. Okay, if I go to the bottom, that cancels. Okay, and you've got 9 minus 3. So if you do 9 minus 3, that's going to give you 6, like that. Okay, just do that in your head. Whatever you can do in your head, do in your head. Okay, but I'm not done. I'm almost done. So I want you to notice on this, see how the 6's are the same, and the 12. Both of those things reduce. You can't just go through and cancel one of the 6's out. The way that you got to do this, and you can do this in your head, is you're really doing 6 root 3 over 6 plus 12 over 6 like that. Okay, now that cancels out, so that gives you square root of 3, and then 12 over 6 is 2. That's your answer, and it doesn't matter what order you put those in. That's it. 2 plus the square root of 3. Okay? All right, does that algebra look okay? Okay? And you're going to have to work with that a little bit in this section, and it's the algebra aspect of this that sometimes students have some issues with. Got to rationalize, and you got complex fractions, okay? And again, I want to remind you on this, like if you're doing like something online, like a quiz or something like that, if your calculator is in degree mode, which it is, you can check and tell this is right this way. So if you were doing a quiz, I'd recommend you do this, because it only takes a few seconds to do this. So if I do tangent of 75, that'll give me the decimal number for that. Then if I do 2 plus square root of 3, whoop, that's wrong. Okay, back up and do this the right way. There we go. So if I go 2 plus square root of 3, it should give the same answer. Okay, so you got the ability to check and verify on a calculator. Okay, all right, everybody comfortable with what I just did? Okay, all right, now I'm going to do one other issue with this, and this one again is just kind of backwards. So this is looking at the identities in reverse. So I've given you the right side of the identity. So first thing is you got to know which identity is this going with. And here's how I know this, is if there's a minus sign there, then it matches that identity. It's the tangent alpha minus beta. That's what tells you that. So that means what we're going to do on this is we're just going to write this as the tangent of 170 degrees minus 50 degrees. Okay, that's why I picked that identity. Does that make sense? Match up the signs. So what you're going to have next is, on this, is that's going to be the tangent of 120 degrees. So then I can just look this up on the unit circle. So that will be tangent of 120, okay, like that. And then you just look at 120, and on a tangent, again, what do? You do y over x, okay? You can do whatever you can in your head. I'm just going to write it as root 3 over 2 all over negative 1/2. The 2's cross out, so you're going to be left with square root of 3 over negative 1, or just write that as negative square root of 3. That's it. You wouldn't be able to do that problem any other way, because tangent of 170 and tangent 50 can only be done with a calculator. Does that make sense? But the combination can be put together. I've designed it so when you put it together, you got an angle that's on the unit circle. Okay, how's that look? Okay. All right. Now, the next type of thing we're going to look at is this type of problem here. I generally always test over this kind of a problem because it's testing your ability to know several things. So let's go ahead and see what we're doing. The first thing on this problem is you're finding the sine of alpha plus beta. And the only way you're going to do that is I didn't give you the angles. I didn't give you alpha and beta. But you have an identity now, so you want to start this problem this way. You want to just write out that identity. Okay, and that identity will actually tell you how to do the problem. And then you got a lot of base background information that we've already learned that'll come in handy. So the identity goes sine of alpha times cosine of beta. Again, you use the same sign. Okay, then it's going to be backwards, cosine of alpha, and then times sine of beta. Okay, so there's basically four things that you have to know. You have to know sine alpha, cosine beta, cosine alpha, and sine beta. So I've already given you some things, and I've given you enough information to basically figure this out then. Okay, so I'm going to slide that thing out of the way because this problem doesn't have anything to do with the unit circle. Okay, so let's see. First thing I'm going to do is I want you to write down a couple of angle diagrams. Okay, there's going to be two of those. We have two angles. First of all, we have tangent of alpha is equal to 15 over 8. Okay, that was a given. And then it gave this condition right here, and that means that your angle is between pi and 3 pi over 2. What does that mean? If your angle's between pi and 3 pi over 2, what does that tell you? That you're in quadrant 3, right? And quadrant 3 is important because it'll give us the exact signs of x, y, and r. So what I'm going to have you do is let's just draw a quadrant 3 angle, a picture of it, and then kind of translate this into a triangle like that. Okay? So what we have is we're going back to stuff we learned about the definitions. You learned that the tangent is y over x. All right? So you're in quadrant 3, so you got to be real careful with this. Y is actually not going to be 15. What's it going to be since you're in quad 3? It's negative, right? That's negative 15, and you have to reason that out. Okay? X is not going to be 8. What's it going to be? Negative 8. Okay, see, the idea with this is I gave you it's in quadrant 3, and still if you did like y over x, you would still get positive 15 over 8. The tangent is positive in quadrant 3, right? Okay, so that gives us that. So what I'm going to do here is, as I'm doing this now, I'm going to write down what x, y, and r are, and then this is going along with angle alpha. You want to kind of keep track of this as we go. So x is negative 8, y is negative 15, and then r, you just do the Pythagorean Theorem, right? Okay, and I'm just going to do this on the calculator. I'm not going to write anything out for the Pythagorean Theorem because we've done that a bunch of times. So I'm just going to do 8 squared, I'm not going to do the negative, it doesn't matter, plus 15 squared. That's going to give that, and then I got to turn around and do the square root because I'm doing a squared plus b squared is equal to c squared. So if I do the square root of 289, that turns out to be a whole number. That's going to be 17. Okay, so we got that. Okay, and that's kind of key in that problem is you got to find x, y, and r. Now the reason that we're doing this, if you go back to what we're doing in this problem, let's work with alpha now. Now you're going to know what the sine of alpha is. What is the sine of alpha based on that x, y, and r? What is it? 15 over 17, right? Because it's y over r, negative 15 over 17. So that's what that is. The cosine of beta we don't know yet. Or actually, I gave it to you. It's there. Okay, we'll work with that in a minute. What's the cosine of alpha based on what we found in this triangle? It's x over r, right? So that's negative 8 over 17. And then the sine of beta, we don't have that yet, but we got to figure it out. So see, what we did is since I gave you the tangent of alpha is 15 over 8, that was enough information to figure out the sine of alpha and the cosine of alpha. Okay, that's one way to do that. Does that make any sense? Okay, don't forget your x, y, r definitions because they're important. Okay, now the next thing is I gave you the cosine is negative 24 over 25. So I'm going to write kind of a new diagram for that. Okay, I also gave you this piece of information. So if beta is between, stop that. If beta is between pi over 2 and pi, that's quadrant 2, isn't it? Okay, so we're in quadrant 2. We're between 90 and 180. So that's what that tells us. So what we'll do to just kind of help us visually is we'll draw a quadrant 2 angle. And let's see, that was cosine of beta is what that is like that. Okay, and you got to find x, y, and r. So the whole purpose of this is find x, y, and r. I gave you a cosine, so what did I give you? What two variables? X over r, right? Cosine's x over r. So that means I've given you x and I've given you r, but I haven't given you y, but we can figure that out with the Pythagorean theorem. So if you draw this triangle, x is the base, that's negative 24. R is the radius, that's 25. So we just need to figure out what y is, and we can do that on the calculator. Now, I'm going to just do this on the calculator. I know it's a Pythagorean triple. I can't remember if it's 7. It might be 7, if I remember. So I'm going to take the square of the hypotenuse, and I'm going to subtract off the square of 24, like that. Don't worry about the negative, and then that'll be 49, and then the square root of 49 is 7. So that means y in this problem is equal to 7. So what we have is x is negative 24, y is 7, r is 25. Okay, if you don't follow what I did on the calculator, just do a squared plus b squared equals c squared, or x squared plus y squared equals r squared, then you'll end up doing that same calculation anyway. Okay, so what's the point of this? Well, okay, what is the cosine of beta now? So look at these numbers. What's the cosine of beta? Negative 24 over 25. I gave that to you anyway. So we're going to put in negative 24 over 25. Okay, right there. And what is the sine of beta based on these numbers? 7 over 25. Okay, like that. Okay, so there's a lot going on in the problem. It's not hard. You just have to be sure you're still on top of the triangles. Okay? Is there anything I need to clarify on that with anybody? Is that everybody following along okay? Okay. Now what I'm going to do now is these are pretty big numbers, so I'll just go through and do my calculator. So if I do 15 times 24, okay, that's going to give 360. So I'm multiplying that fraction straight across. Then if I do 17 times 25, okay, that's going to give 425, like that. Then I'll go over and do this. Now that's a positive, and over here it's negative 56. And then 17 times 25 is 425, like that. And then I've already got a common denominator. You're pretty well always going to have that case in this problem. So we got 425, and then if you do 360 minus 56, that's going to be 304. So that's it. It's a weird answer, but that's the answer. Okay? All right? So the key thing on that one is when you write out the identity, which I did right here, it ultimately tells you need to know 4 things: sine alpha, cosine beta, cosine alpha, and sine beta. The rest of it's triangle. Okay, does that make sense? Okay, so you're going back to those definitions again to figure this out. Okay? Okay, so I just usually like to show one problem like that. There's a lot of work, but just be really careful with the signs in your definitions. Okay, next thing I want to do is a couple of proofs. And the proofs in this section are actually easier than the proofs that you've already done, okay, in my opinion, because it's very straightforward how you do this. So we're going to prove this identity. Okay, so what we want to do to start with, like I showed you, when you do a proof, you want to write down the word proof, and then you want to pick a side that's more complicated, and the more complicated side is cosine of x plus pi over 2. Okay, like that. And there's no guesswork on this proof. When you see the cosine of a sum of 2 angles, there's only one thing to do, and that's apply that identity. So we're going to use the cosine identity that goes cosine, cosine, sine, sine, different sine. So let's go ahead and write that down. Put it in the identity, and let's see what happens. So we would say cosine of x times cosine of pi over 2, like that. cosine, cosine, sine, sine. Now we go sine x times sine of pi over 2 like that. And then remember this identity says we have a different sign. That's it, okay? Now what we're going to do is this really looks a lot like a unit circle. So you need to figure out what those two things are on the unit circle, and then we'll see what happens. So at pi over 2, which of course is 90 degrees, you have the point 0,1. So what's the cosine of pi over 2 going to be? 0. What's the sine of pi over 2 going to be? 1. Okay, like that. Okay, so we're using that identity. Now let's see what happens. You'll have cosine x times 0 there. Then you'll have minus sine of x. And sine of pi over 2 is 1. Everybody follow that okay? Okay, now see if you have a cosine sum like you have there, you got to use that identity. And then that will cancel out. And then this will leave you negative sine x. That's what you were trying to prove. So that's it. Okay. When you're doing this type of a proof, it's pretty straightforward with using the identities you learned in this section. That's the idea. Okay? Does that seem easy enough? Does that everybody follow that pretty well? Okay. All right, let's do one more proof here. Now let's see how this one works. This one's probably a little bit more work, but what I'm going to do on this is I'm going to write down the left side because it's a little more complicated. It has more stuff. So I've got sine of x plus y minus sine of x minus y like this. So a proof like this, you don't, just kind of play with it like some of the other ones. You have to do these identities. So what we're going to do is we're going to do the sine sum identity and the sine difference identity. So I'm going to just kind of set it up like this, and I'm going to put the results of those two things in two brackets. So you're actually just going to pull out the formula that we learned for the sine sum, and that's the one that goes sine, cosine, cosine, sine, same sign. So when I do this identity, I'm going to go sine of x times cosine of y. Then I do it backwards. I go cosine of x, sine of y. Then I use the same sign. So that is your sine sum identity. Okay, look it up until you have it memorized if you don't have that yet. Now do the next one the same way. This is a sine difference identity, so it goes sine, cosine, then backwards, cosine, sine, and then again same sign like that. So see that plus there matches that, the minus there matches that. Okay, so what do you suspect is going to happen on this problem? I bet things are going to cancel out because you're trying to, whoa, what happened? Okay, well, everything's still working. Okay. There we go. Okay, wow. Now, let's go ahead and let's see what cancels and what goes together here now. So, and you got to be careful with your signs. So you have sine x, cosine y, plus cosine x sine y. Okay, now distribute the negative. Be careful with this. You're going to have minus sine x cosine y, like that. And then when you do a minus minus, that's going to give cosine x sine y like that. Okay, it's just like terms now. So does anything cancel? It looks to me like this and this are the same, but one's positive, one's negative, so that cancels. Okay. Now, how about what's left over? You have cosine x sine y, cosine x sine y. What do you do with that? Those are like terms, right? So you just add them together. You have 1 plus 1, or you have two of those. So you have 2 cosine x sine y like that. Okay, that's it. That one's pretty straightforward. It's mostly algebra and then just knowledge of the sine sum and difference identities. Does that look okay? Okay, that's not even fun like the other ones. It's just kind of straightforward. The proofs in this section are actually pretty easy. Okay? Okay, so I want to do, there's one last thing I want to show you in this section is, this is just another way of looking at a sine sum difference identity. So this one right here is the one, if you don't set it up right, you would probably struggle a lot trying to figure this out. Okay, so what I want you to do first of all is I want you to write down what I've already written down there. What we're going to do is we're going to let A is going to be this part of the problem. It's going to be inverse cosine of 1/2. I'm going to let it be a variable. okay, then B is going to be this part. And I'm doing that for a good reason. It's all because of the identity that we learned in this section. Okay, so you want to get that written down. Then what you want to do is write this out like this. Okay, this is now going to be sine of A minus B. Okay, you just substitute in for A and B like that. All right, now by doing that, what we can do on this is we can use that sign difference identity. So the next thing we're going to do is we're going to go ahead and write out the identity that goes sine, cosine, cosine, sine, and then same sign. So let's write that down. That's sine A, cosine B, then do it backwards. You'll have cosine A, and then sine B like that with the same sign. Okay, now that's going to kind of lead us through what we do in this problem then. Okay, now what we're going to have on this now is this particular problem can be thought of with the unit circle, but you actually don't even have to do the unit circle. You can kind of do this way. So I'm just actually going to cut the unit circle and show you what we're going to do. Okay, so if we have A is equal to inverse cosine of a half, what that really means is this. It really means that I have given you X and I have given you R. That's what that means. You don't even care what that angle is. It doesn't matter. Okay, so what we have for angle A, we have X is 1, we have R is 2, and then you'd have to find Y with the Pythagorean Theorem, right? Okay, and if you did that with the Pythagorean Theorem, and I'm not going to do that, I don't want to spend the time on the Pythagorean Theorem, you'd get square root of 3. And you probably already know that because that's a special triangle, 1, 2, root 3, right? The other thing is, since this is the inverse cosine has a range from 0 to pi. That's the range that we learned. So since that's a positive number there, that means you're in quadrant 1. So that means everything's positive. Okay, so that's what that gives you. So what do you do with this stuff? Well, the sign of A is in these numbers. So what's the sign? The sign is y over r. So that means that's going to be square root of 3 over 2. That's what that is. Okay, if you go over to the cosine of A, that is x over r, so that's 1/2. Okay, so I've done that. See, I don't even need to know what the angle is to do this problem. It's not important. So the next thing I need to do is we need to look at the statement for B. We have the statement that is this. B is equal to inverse sine of square root of 3 over 2. So what does that mean? The sign is what? Y over r. Okay, we're in quadrant 1. You know why we're in quadrant 1? Because the inverse sign is defined from negative pi over 2 to pi over 2. That's a positive square root of 3 over 2. That's what forces you to be in quadrant 1. Okay, and then what you would have is you would have y is equal to root 3, r is equal to 1. So what's x? I hope you already know that. What is it?
2.
Oh, hold on. Maybe we don't know that. No, it's not 2. We got to do the Pythagorean Theorem. I was thinking it all depends on where that square root of 3 is. The radius is 1. The radius is not 2. So let's go ahead and do x squared plus y squared equals r squared here. Okay, so we're going to have x squared plus root 3 squared is equal to 1 squared. So that's going to be x squared plus 3 equals 1. So it looks like that's going to give square root of 2. And I'm going to do that real fast, just kind of do stuff in my head. So the square root, x is equal square root of 2. Okay, like that. Okay? Whoa, that doesn't sound right.
2.
What in the world am I, hold on, let's see. What in the world am I doing? Ah, you know what I did here? Okay. I do stupid stuff like this. What's r? 2. I put 1. Why? I have no clue. So somebody said x was 1. You were right. Okay? You see what I mean? Okay? I just wrote the wrong thing down. So forget all this mess because I wrote that down wrong. So what you're going to have is you're going to have this. Okay, so we got that. Pythagorean Theorem. All right, everybody with me okay? Okay, all right. Now, tell me what the cosine of B is. Look at those numbers. What is it? X over R, right? So it's 1/2. Good. Okay, got that? What is the sine of B? That's y over r. So what's that? Square root of 3 over 2, right? Okay. So now we're ready to put this all together and get our answer like that. Okay. So now what do we have? We have square root of 3 over 4 like that. Could this be 0? I guess it could be. I'll look at it in a minute. And then that would be square root of 3 over 4 like that. So that appears to be 0. It could be. Okay. And actually, I'm going to show you back on that unit circle. I'm going to show you kind of why that would be the way it is. Okay. This problem right here, you could look at the unit circle, but you actually don't have to. So if you're looking at this, here's what happens in this problem then. So basically, if you're doing an inverse cosine of 1/2, what you really have is you have a 60-degree angle, right? If the inverse sine of square root of 3 over 2, that's also 60. Okay? See, that's the idea. So the angle that has a cosine of 1/2 is 60. The angle that has a sine of square root of 3 over 2 is also 60. So here's why we got 0 for an answer, because this is really the sine of 60 minus 60, right? That's the sine of 0. What's the sine of 0? 0. Okay? So see, you can do that with or without the unit circle. So the math, we did everything exactly right, so it just worked out that that angle was the same. Does that make any sense? This is probably the hardest problem in the whole section right here. This is the one that's the most abstract and has the most knowledge that you're being tested over. Great problem, because there's all kinds of little things going on in it. Okay, any questions about that? Okay, I'm going to do one more, kind of finish this up. And then this one, the unit circle doesn't do us a bit of good. So let's see this, if we get this down a little bit better. The approach on this is going to be exactly the same. So I'm going to let that be A, and I'm going to let that be B. So what you want to do is you want to write down that A is equal to inverse sine of 2/3. Then we want to write down that B is inverse cosine of 1/3. Those are not numbers that are going to be on the nice unit circle. Okay? But what we're going to do is we're going to go ahead and find X, Y, and R on these things. That's going to be the idea. So in this particular problem, since we know that the sine is Y over R, that means when we're dealing with angle A, we need to find X. We know Y is 2, and we know R is 3, right? Now, what do you do to find X? You do the Pythagorean Theorem, okay? If you go through and do that, you would have X squared plus Y squared is equal to R squared. So that's X squared plus 4 equals 9. And I'm going to do that real fast. So that's 5. So that's going to be square root of 5. Okay, you're in quadrant 1 because that is a positive quantity. Okay, like that. Anytime you're doing an inverse trig function of a positive, you're in quadrant 1. Okay, so we got that. Now let's go to the cosine of B. What's the cosine's definition? X over R. So I gave you X and I gave you R. Okay, so let's write it down. X equals 1. We don't know Y, but we can figure it out. That's equal to 3 like that. R is 3. Okay, again, it's Pythagorean Theorem. So you would have X squared plus Y squared equals R squared, like that. That's going to be 1 plus Y squared equals 9. Subtract 1 from both sides, you get Y squared equals 8. Square root both sides, you get that. And then that breaks up into 4 times 2. So that's going to be 2 root 2. Okay, I don't do all that Pythagorean Theorem stuff fast because we've done it so much. Okay, so we got that. Is everybody with me on that? Okay. Now, what we got to do, finishing up the problem is actually very easy. What we do is just write this down now as sine of A plus B. And what we're going to do is we're going to pull out that identity that we learned for the sine of A plus B. And then we're going to put it all together. So if I do that, what I'm going to have is sine of A, cosine of B, same sign, plus, and then do it backwards. Cosine of A, wave your hand again, and that seemed to work good. What's going on with that thing? Okay, well, I kind of like it like this. I'll get up in a minute if it doesn't come back on. So we got cosine A, and then we got sine of B like that. Okay? You guys with me on that, okay? Look at that, all I had to do was get up and walk and it came on again. So I put on I guess something like that, like one of those detectors, motion detector. Okay, let's see what we got here. All right, now let's finish this up. Okay, the sine of A. Can you tell me what the sine of A is? 2/3, good. Okay, it's right there, it's y over r, 2/3. Okay, cosine of B, you got to look down at these numbers. What's the cosine of B? 1/3, good. Okay, so that's going to be 1/3. And then cosine of A. Go over here for cosine of A. What's that? Square root of 5 over 3. Okay, so we got that. Sine of B, go over here. What's that? 2√2 over 3, because it's y over r. That's it. Everybody see where I'm getting those magic numbers? Y over r, x over r. Okay, that's what we have. Okay, so now when I put this together, this right here is going to be, that looks like 2/3 there when you multiply that straight across. Okay, multiply this straight across, that's 2 times the square root of 10. And not over 3, that's over 9. Okay, 3 times 3 is 9. So we have 2 over 9 plus 2 root 10 over 9, like that. Then we should be able to put it together, and then we got an answer. Okay, so that's going to be 2 plus 2 root 10 over 9 would be the final answer to that problem, like that. Assuming I didn't make any arithmetic mistakes, and I think I'm okay. I've got the identity right. I think I've got all the x, y, and r stuff right, so that should be okay. All right? Okay, any questions? That's probably the most challenging problem you do in that section. And when you do that, when you say it in the homework, follow that those directions exactly the same way, because you aren't going to get it any other way. You've got to change that into a sine A plus B so you can use that identity. That's the idea.